Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing developments in science and technology. And with us today is Professor David Weintraub, Professor of Astronomy at Vanderbilt University, author of a brand new book, Life on Mars, What to Know Before We Go, a great book about some of the exciting developments about the planet Mars. And you know, the President of the United States has made it official. A presidential statement saying that, yes, we're going to go back to the moon, then on to Mars, and then even beyond that. So first of all, David, tell us a little bit about how you first got interested in astronomy as a young kid.
I was always fascinated by the sky, but I was not somebody who had a telescope and looked up. I read science fiction. I grew up during the early days of the space age when NASA was busy launching the first missions to Mercury, to Mars, to the moon, and I just grew up thinking that space was the most fantastic thing I could possibly learn about.
Okay, well, your book is about Mars. First of all, why not Venus or why not Jupiter? Why did you focus on the planet Mars?
Well, it's less than that I focused on Mars. It's that astronomers collectively have focused on Mars as the planet that is most likely to possibly host life. Since the very beginning of the age of telescopes, astronomers started poking their telescopes at the planets in the solar system and found that Mars is the one that is really most like the Earth. Mars has a rotation period which is just a fraction longer than 24 hours, so it's just like the Earth in that respect. Several hundred years ago, astronomers discovered that Mars has polar caps. The rotation axis of Mars is tilted almost the same angle away from the direction of the sun as is the Earth, and that's what gives Mars polar caps. And as a result, Mars has seasons just like the Earth. And Mars is a solid planet with a little thin atmosphere above the surface, just like the Earth. All of those things contributed over the first few hundred years of the age of telescopes to astronomers thinking that Mars was Earth-like. And so astronomers studied Mars quite intently in the 19th century, and they thought they discovered things that they really hadn't seen. They thought they discovered water on Mars, and they hadn't, and they thought some of them had thought they discovered canals on Mars, which of course are not actually canals on Mars. They're just, dark and light surface features on Mars. But by the end of the 19th century, the combination of correct information about Mars and some incorrect information about Mars had convinced a lot of scientists, a lot of astronomers, that Mars could really be a place where life might exist, where Martians might exist. And I think that cultural result still informs the way we think about the planets. We know that the moon is dead. We know that Venus can't possibly host life. Mercury has no atmosphere. Jupiter and Saturn are pretty hostile places. So among the planets that are close to us, Mars is just the most appealing place, and it is very appealing for all these reasons.
Now, as I understand, the astronomer Schiaparelli back in the 1800s said he observed canali on Mars, and canali was translated into English as canals, and there's a big difference, right, between a channel and a canal. What's the difference between the two that created the Man from Mars myth?
There sure is a big difference. Canali in Italian could mean the English Channel. It could mean a river flowing down the mountain. In most cases, it implies a natural formation with water flowing rather than a engineered, man-made structure. A canal in English is almost always intended to mean a man-made canal, like the Erie Canal or the Suez Canal. And at the end of the 19th century, human engineers were building these big canals on the Earth. So the translation of canali into canal in English wasn't correct, but it was influenced by partly what astronomers, especially Percival Lowell, wanted to see on Mars, but also it was influenced by what we were seeing happening here on the Earth, the building of real large canals.
Okay, and then, of course, H.G. Wells wrote that famous novel, War of the Worlds, and apparently he wrote it asking himself, what would somebody in the third world today feel if they saw the British Empire come with their gigantic gunboats for the first time? So in some sense, we are the Earthlings watching the British Empire take over the world. So wasn't that a game changer? All of a sudden, the planets, instead of being dead and simply bright lights in the night sky, could actually harbor life, maybe even hostile life forms, right?
I think H.G. Wells, as one of the pioneers of science fiction, certainly created this idea that extraterrestrials might be bad or bad for us. They might be warriors that we should be afraid of. I don't think that idea existed in science fiction, or at least it wasn't a prominent idea before H.G. Wells put it out there. And, of course, when Orson Welles brought War of the Worlds across the ocean and set it in New York City and New Jersey, bringing it closer to home for listeners in the United States, that changed it even more, turning the Martians into real hostile beings who became scary.
Okay, now today, of course, we've mapped the entire surface of Mars. In fact, we know more about the surface of Mars than we do about the surface of the Earth, because most of the Earth is covered by oceans. And some people have claimed over the years that they see strange formations on Mars that resemble, well, life forms, faces on Mars. There's even a structure that looks like Kermit the Frog on Mars, and another structure that looks like Buckingham Palace on Mars. But aren't they all basically illusions of the human brain, our eyes playing tricks on us?
I think they almost certainly are. Just like the work by Schiaparelli and Lowell 100-odd years ago that led them to think there were canals on Mars, I think people can be creative in imagining that they see what they would like to see. The images don't lie. The images are simply images. It's up to us to interpret and understand those images. And almost all, probably all the formations that we've obtained images of on the surface of Mars, they're all natural formations. You can get a formation that looks very square. You can get a formation that looks jumbled. They're natural formations.
Okay, David, we have to take a short commercial break. And after the break, we're going to continue a discussion of this new book, Life on Mars, What to Know Before We Go, by astronomer David Weintraub. Science Fantastic with Professor Michio Kaku. In this hour, we're going to explore the universe. We're going to talk about Mars. We're going to talk about extrasolar planets. And we'll talk about, well, aliens from outer space. What do scientists believe is out there in the Milky Way galaxy? Now, David, before the break, we talked about looking at the surface of Mars with our satellites and our rovers. And they have not detected signs of life, but they have detected signs of water, flowing water, rivers, perhaps even an ocean bed. So tell us a little bit about what we actually find on the surface of Mars.
We find on the surface of Mars a great deal of evidence that said lots of water used to be flowing on the surface of Mars. We haven't found any substantive evidence that any water is flowing on Mars today. But in the past, billions of years ago, there were vast channels. We're back to the word channels again. We've called them outflow channels and runoff channels on the surface of Mars. Some of them look like rivers. Some of them look like catastrophic flows from glaciers that may have melted or from underground reservoirs which might have burst onto the surface. So we know Mars had a tremendous amount of water on the surface in the past. What we see now is ice at the polar caps, and there's some evidence for ice below the surface as seen in some of the measurements made by some satellites. But we haven't found nearly as much water frozen on Mars today as we think was there once. The total amount of water that we see now, if we could extract it and melt it and put it on the surface, would create an ocean on the surface of Mars that was about 69 or 70 feet deep. And while that sounds like a lot of water, the total amount of water that we think Mars had in the past would be an ocean about 1,000 feet deep. So most of the water that Mars once had that carved the fluvial features on the surface, we're not finding. And either that means that most of Mars's water is buried deep underground where we simply haven't found it yet, or a great deal of Mars's original reservoir of water has been lost to space.
Okay, well, here's a $64,000 question. What happened to the water on Mars? I've seen some reports saying that once upon a time, there might have been an ocean about the size of the United States of America on Mars. But the question is, what happened to the water?
Some of the water certainly is still there. Much of the water, as I said a moment ago, might be underground. But Mars could have lost a great deal of its water to space. Because Mars does not have the kind of atmosphere the Earth has, in particular, Mars has no ozone layer. The materials in Mars's atmosphere or the water on Mars's surface has no protection from ultraviolet light. And ultraviolet light from the sun can bust up a water molecule into the individual hydrogen and oxygen atoms. And then the hydrogen atoms, because they're very, very light, could bubble up to the top of the atmosphere. That by itself isn't a problem, but when you combine that with the fact that Mars has no magnetic field, the magnetic field of the Earth protects the Earth from what's called the solar wind, which are very high-energy particles flying out from the sun at speeds of hundreds of miles per second. And that solar wind acts like a sandblaster on the top of Mars's atmosphere and gradually erodes the particles away from Mars that are at the top of the atmosphere. So those hydrogen atoms, which have been busted up by ultraviolet light, could have been sandblasted off of Mars by the solar wind, and as a result, Mars could have lost a great deal of its atmosphere through the combination of having no protection from ultraviolet light and having no protection through a magnetic field from the solar wind.
Okay, well, let's talk now about going to the planet Mars, which is a goal of the United States of America. Sometime in the 2030s, according to the presidents of the United States, we hope to send a manned space expedition to Mars. And so, first of all, the movie, The Martian, starring Matt Damon. Have you seen that movie, and do you think it's relatively realistic?
I have seen the movie, and I think it's a fantastic movie. I think everybody interested in Mars should see the movie if they haven't yet. It is very realistic. There are just a few things that I think the writers and the screenwriters had to push a little bit. So, for example, the spacecraft that almost falls over at the beginning, that forces a number of the astronauts to escape from Mars, leaving Matt Damon behind, I don't think that could happen. Mars has tremendous windstorms, but because the Martian atmosphere is so thin, that windstorm has no momentum. It would have a very hard time blowing over a spacecraft. So I think that was a nice piece of imaginative writing that enables the rest of the story to happen, but I'm not sure that would actually happen. The rest of Damon's experiences on the surface of Mars, I think, are exactly right, or at least reasonable. Trying to grow potatoes the way he did, trying to deal with the Martian environment the way he had to, trying to navigate on the surface of Mars. I think all that was done very, very realistically.
Okay, now let's talk about terraforming Mars, which is not a short-term goal at all. But over the decades, maybe even the centuries, some people have thought about, well, what would it take to create a Garden of Eden on Mars? So let's talk about some of the ideas that have been floated by science fiction writers and NASA scientists. Some people say, for example, that we can use genetically modified algae and genetically modified crops to grow in this atmosphere of carbon dioxide, to grow in a relatively cold environment, and perhaps create agriculture. First of all, what are your thoughts about that?
I think the science fiction writers usually are pretty far ahead of the rest of us in thinking about things like this, and they have very imaginative, creative ideas, many of which may really work. Certainly Mars is rich in carbon dioxide, so that makes it a healthy environment for plants, and Mars has plenty of sunlight for plants to grow. If the plants could find enough water, then perhaps that could work. Plants probably would find Mars a relatively friendly environment. For us, not quite the same thing because we need oxygen, but for the plants, I think they could be successful on Mars.
Okay, and also we've had Dr. Zubrin on the airwaves who talks about perhaps melting the polar ice caps. Perhaps one day in the future we'll have solar satellites that beam solar energy concentrated on the polar ice caps, melting them, and liquid water would then flow freely on the surface of Mars once again. So what are your thoughts about that proposal of melting the polar ice caps?
I think it's feasible. Again, we're talking about something that would take probably centuries to do, but I think melting the ice caps might be premature because I think you need an atmosphere that is a little bit warmer than the current atmosphere in order for anything you melt to stay melted. At the moment, if you beamed some solar energy down on the ice caps and melted some of the water, it would freeze again because the atmosphere is too cold. So I think a first step would actually be trying to figure out how to warm up the planet. Then you could try to melt the ice caps.
Right. And according to one calculation that I've seen, that if you could raise the surface temperature of Mars by 6 degrees, perhaps inducing a greenhouse effect by introducing methane gas into the atmosphere, but if you could raise the surface temperature by 6 degrees, then the greenhouse effect turns into a runaway greenhouse effect. It feeds on itself and it spirals upwards, and that could lay the foundation of terraforming Mars. So what do you think about that idea of getting it up to 6 degrees using some sort of greenhouse effect, and at that point creating a runaway greenhouse effect?
I think the greenhouse effect is what we have to do in the Martian atmosphere to terraform it, to warm it up, but we know so little about the consequences of what we might do that I think we need to think pretty hard and be pretty cautious about this. You used the words a runaway greenhouse effect. That would not be what we want. Venus has a runaway greenhouse effect in which the atmosphere is warmed up to almost 1,000 degrees. That's not where we want to go. That's the runaway.
Science Fantastic with Professor Michio Kaku. With us on the line is Professor David Weintraub of Vanderbilt University, author of an exciting new book just hitting the stands now, Life on Mars, What to Know Before We Go. And Mars is going to be in the news. NASA is launching the InSight probe to Mars, which will then try to answer questions like what happened to the magnetic field of Mars? How active is Mars geologically speaking? Are there Marsquakes on Mars? But let's move on because we want to talk about, well, life throughout the universe. Let's talk about TESS. TESS is the latest development in our discovery of extrasolar planets, of which we have discovered at least 4,000 circulating around other planets, other stars in the Milky Way galaxy. And the workhorse of that was the Kepler satellite. However, the Kepler satellite is currently crippled, and of course we now have a replacement called the TESS. So first of all, David, tell us a little bit about what we learned from the Kepler satellite, which many people think was a game changer in our understanding of planets in the universe.
That's a good description. Kepler did completely change how we understand planets beyond the Earth, beyond our solar system. Prior to the launch of Kepler, we knew of a few dozen planets from observations made from telescopes down here on the Earth. Kepler has found nearly 4,000 planets around other stars, and Kepler has only surveyed a very, very tiny piece of the Milky Way galaxy in the constellation Cygnus. So the number of planets Kepler has found indicates that the Milky Way galaxy probably has tens of billions of planets.
Now, isn't that really a game changer, that we can actually take a census of the Milky Way galaxy and thereby compute that there could be literally billions of Earth-sized planets in our own backyard? Isn't that really a game changer?
It's a game changer. It's not a guess. it's using statistics, and all of us understand statistics reasonably well. If I go outside and look at 100 people and I discover that their average height is about 5'7" or 5'8", I could reasonably conclude that if I find 100 other people, I will find that their average height will be in the ballpark of 5'7", 5'8". When we study the 100,000 or so stars that Kepler studied, we're getting a good statistical sample that's representative of all the stars in the Milky Way. So if we know that those stars have 4,000 planets, and we know that most of those stars that we're studying are not oriented in such a way that we could even discover their planets, we know that just about every star we look at will have a planet or more than one planet. And statistics don't lie. If we have any kind of survey sample and we get a robust result from that survey, we can extrapolate that to the entire population of objects and be fairly confident that we have a good answer. So since we know the Milky Way galaxy has a few 100 billion stars, and we know how many planets are within the sample of the Kepler survey, we can then extrapolate pretty accurately to how many planets should be in the entire Milky Way. And it's a huge number.
Now, originally, the planets that we discovered were Jupiter-sized, that is, gigantic gas giants that were probably unsuitable for harboring life. But now we're finding Earth-sized planets out there, which is really amazing. Perhaps we're going to find twins of the Earth in outer space. That would really change everything. We've been talking about extrasolar planets, 4,000 of which have been identified by the Kepler satellite, which unfortunately is now crippled. But we have a replacement called TESS, which is going to scan not just one segment of the Milky Way galaxy, but the entire night sky. Amazing. We're going to be able to scan pretty much the entire Milky Way galaxy looking for planets that may resemble the planet Earth. So, David, do you think that TESS is going to greatly expand the number of Earth-sized planets that we've cataloged in outer space?
It should. TESS is expected to discover several hundred Earth-sized or super Earth-sized planets. All of those planets are going to be what's called in the solar neighborhood. That, to me, is the most exciting part of TESS. It looks in all directions, and in that sense, it's looking in every part of the Milky Way or in every direction of the Milky Way. But TESS will only be studying about 200,000 stars, which are among the closest stars to the Sun, not the entire galaxy. But that means that the planets we discover will be close enough that we might be able to study them in a great deal of detail after we know where they are. That's the real power to me of TESS, finding planets which are close to the Sun.
And I understand that the Webb Space Telescope, the replacement for the Hubble Space Telescope, is powerful enough to perhaps, and this is a big perhaps, actually photograph some of these extrasolar planets. I mean, isn't that amazing that if TESS can identify a whole bunch of these Earth-sized planets, we might be able to actually have photographs of these planets taken by the Webb Space Telescope to be launched within 2 years or so. Isn't that amazing?
I think it is amazing. We need to be a little bit cautious, though, in thinking about what the Webb telescope will show us for these planets. I think what they will show us is a little dot. Almost all of them unresolved dots. So we will be able to see the planets rather than just detect indirect evidence that they exist. So with Kepler and with TESS, we're detecting indirect evidence of the planets. We're detecting, in effect, the shadow of the planet as it goes across the face of the star. With the Webb telescope, we should actually be able to image the planet directly, but we're not going to see a pretty picture of the surface or the atmosphere of the planet. We're just going to see a little dot that is the planet. Now, because we can see that little dot separately from the star, we can study the light from the planet itself and learn things directly about the planet and about the planet's atmospheres. So that will be something the James Webb Telescope can do. But we, again, shouldn't expect pretty pictures like we see of Mars, like we see of Venus, like we see of Jupiter. We're not going to have those kinds of pictures.
Okay, now, we usually ask the astronomers that we have on Science Fantastic the key question. First of all, do you believe that there could be intelligent life in outer space? And if so, well, how come they don't visit us? Or maybe they have. What are your thoughts?
I'm skeptical. I don't think we have any real evidence that there is intelligent life beyond the Earth right now. There certainly isn't any evidence that I think is robust enough to believe that anybody has visited us, and there's no evidence that we can see in the Milky Way galaxy of other intelligent beings colonizing or traveling through the Milky Way galaxy. I think a lot of astronomers think that if intelligent beings more advanced than us existed in the Milky Way, we'd have noticed their presence already, and we haven't. But intelligent life beyond the Earth is a different question than whether life itself exists. And I think I'm less pessimistic about the possibility of primitive life, bacteria, viruses, very primitive life beyond the Earth than I am of intelligent life.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today, once again, is Dr. David Weintraub. Well, David, before the break, we were talking about the possibility of life in outer space. You said that, well, you're kind of skeptical that we have any evidence today of visitation. But then the other question is, well, since there's so many planets out there and the possibility of life is non-negligible, then, well, how come they don't visit us? Is it because there's simply too few intelligent races out in outer space, or perhaps they're not interested in us? What are your thoughts? How come they don't visit us?
I think there are a tremendous number of unknowns about what intelligent life might be like if intelligent life does exist beyond the Earth. We can't assume that they would think or be like us. So maybe they would have no interest in exploring. Maybe they have not reached the point in their intellectual development where they've developed rocketry and engineering. Maybe they just developed those interests but feel no compulsion to travel. So we can't understand them if we don't know they even exist. Science fiction writers, again, have thought a lot about extraterrestrial life, so they have lots of good ideas, but that doesn't mean we understand what they would be like at all. We're heavily influenced by the movies we see and the science fiction books we read, but we just don't know anything. It makes it very hard to speculate. One possibility is that even if they exist, we are the most advanced civilization in the Milky Way. We know that on Earth, we needed almost 4 billion years from the formation of life to the formation of intelligent life. So intelligent life might actually be very, very difficult to come into existence, even if life has formed on a planet. Life existed on Earth as far back as about 3.8 billion years ago, but we didn't even have plants or animals of any type until 500 million years ago, and then it was another 500 million years until we came into existence. So we may, in fact, have a big head start on other planets. It may be that the Milky Way galaxy couldn't produce planets that had the right atmospheres and the right conditions to make life until 5 billion years ago. We just don't know.
Well, you know, the science fiction writer Arthur C. Clarke once said, quote, "Either there are intelligent beings in outer space or there are not intelligent beings in outer space. Either way, it is frightening." And let's talk about that for a moment. My colleague Stephen Hawking, who recently passed away, made headlines years ago by saying that we should not deliberately send evidence of our existence in outer space because we don't know who's going to be listening in on us, and they may be hostile. And he quoted what happened to the Aztecs when they encountered Cortez. Cortez, they thought, was a god. Unfortunately, he turned out to be a bloodthirsty plunderer who destroyed the Aztec civilization. So Stephen Hawking said, therefore, let's not advertise our existence to aliens in outer space until we know a little bit more about their background. So, well, what are your thoughts?
I think we've already advertised our existence. We can't prevent advertising our existence. We could decide, we shouldn't send radio broadcasts or television broadcasts into space. Well, we've been doing that for 100 years, or nearly 100 years now. Those signals that say intelligent life exists on Earth fill up a volume of space 100 light years in radius from the Earth, and they will continue going outwards. We can't get them back. I think the idea that we should close down shop and not send signals into outer space is a fairly silly one. One, because it's impossible to do, and two, because the barn door's open. We've already sent those signals out, and if there's anybody out there listening, they'll hear us. We can't prevent that at this point. So I think that idea doesn't really make a lot of sense to me. We have no way of judging whether someone who might hear our signals, if there's anybody out there, will be friendly or hostile. But I think it's impossible to prevent them, if they're out there, from knowing we're here. In fact, if someone
go on.
even without the radio signals, even without the signals we're sending out, if some advanced civilization simply could identify the Earth as existing, they could point their telescopes at the Earth and prove that life exists on the Earth, and probably that intelligent, advanced life that's capable of manipulating the environment exists on Earth. So the information's available no matter what we do.
Okay, fair enough. Well, some people have said that if there are intelligent beings in outer space, they may not want to plunder us because there are other planets out there to plunder that are not inhabited by any restive natives. So instead of the aliens coming to Earth because they want to steal something or they want to destroy us for a particular reason, there are plenty of uninhabited planets out there with plenty of minerals and resources and energy that they can plunder without having to deal with intelligent life forms. So maybe they'll just leave us alone. Well, unfortunately, we have run out of time. But if you want to know more about these questions, get a copy of Professor Weintraub's latest book, Life on Mars, What to Know Before We Go.